Hey guys, what's up? Eddie Aho here with KissAnalog.com. Today we have a little gift here. It was sent to me by Zotek, which that was really awesome. I guess they liked the reviews, or I've never reviewed a Zotek meter, but I guess they wanted me to. So let's break in here and see which meter they sent. Now the nice thing about this is, let's make sure before I say anything. Yep, they did it. They've been really nice, and they asked what else they could do, and I said, well, send 2 meters so I can give one away. I don't know a whole lot about the Zotek meters other than they make a lot of meters for other people. They've got branding. They don't even have the name on this. This is like unbranded, guys. That's interesting. 1-year warranty, it says on the front. That's about it. Digital multimeter. That's what the picture looks like. Wow. That's actually feels like a nice manual. Now I can tell you, just talking to the people there, I'm pretty sure they're coming from China, well, at least emails, and very fluent in English, and their manual looks the same. That's impressive. Okay, so I'm going to look up the price for this. I wasn't sure which one I was getting sent. This is ZT219 True RMS meter, so it's True RMS. Right here it says 1999 counts. That's crazy. That's crazy good. 1000 volts Cat 3, 600 volts Cat 4. That category 3, 4 stuff, you know, that I've done some videos on categories. That's more for professional use. Category 1 and 2 here at the bench, AC, DC power. So it should be fine for that kind of stuff. Now, wow, it has a 20 amp input. That's surprising. A lot of multimeters, I understand, have gone away from the 20 amps. I think as far as getting a UL safety agency reading, they thought that was too much energy. Now I guess it depends on what voltage it's at, right? But so that's why they did away with that. It says CE on the front. Okay guys, let's bring the camera on over, take a close look at this thing, and I'll walk through the meter with you, okay? And we'll take some readings, but man, right now, relative, range, min, max, it's got a lot of good stuff around it, so, and 20,000 counts, well, 19,999. Anyway, let's bring the camera over and take this thing through its paces, and we'll talk about how we're going to give one away throughout the video, okay? Yeah, it's got the CE mark on back. Some people joke that that's Chinese export, or maybe that really was a real thing. I don't know, but anyway. Alright guys, bring the camera over. Alright guys, so this is what it comes with. The meter, the manual, this temperature probe, and test leads. We'll take all this out of the case, but anyway, you know, the case is padded. It's kind of soft on the inside. It's kind of a nylon fill on the outside, I think. It's got a strap here, and you know, the zipper's okay. A lightweight bag. I mean, I don't know what a bag like this would cost, especially coming from China. I'd imagine fairly inexpensive. I just think it's cool that you get a bag, keep all your stuff in. That's just a nice touch. Whenever you store something in a bag like this, I'd put the meter face down against the top, put everything else on the other side. So the meter has a nice protective thing. The leads aren't scratching it. I think we're going to take off this little protective thing. I like how nice and shiny that looks. Alright, and then the manual, like I said, it looks like it's well written, and it's a nice manual. It actually explains each feature and function pretty nicely. By the way, this meter has some really cool functions in it. One thing I want to point out, when you power the meter, you can put it in, you can hold select button when you turn it on so it does not turn off automatically. If you want it to turn off automatically, just turn it on normally. It turns off in 15 minutes. 1 minute before, it'll it'll beep 5 times. So that's always something nice to know about your meter. So there's your display, and it's got a lot of stuff. It's got a little battery feature there to show you low power mode. We're going to find out what frequency band this is good to. And you know what? I really like, actually, I'm a fan of this non-contact voltage thing. So you don't have to actually, you know, if you can sense voltage without having to probe it. But yeah, there's your specs if you want to look at that. Alright, so let's just open up these guys, see what they look like. Holy cow, I didn't notice that. This is one of those ones with the probe. Wow, I like that. That's pretty cool. You know, especially if you have multiple meters, you always have those other little temperature probes, so it's nice to have one like that. That is cool. I like that. That's a neat temperature probe. I'm sure they're PVC, they're not the silicone. But you know what, these, I think the reason why they don't just automatically give you silicone is the PVC is strong, it lasts a long time, it's pretty rugged. There's your CE marks. It feels like pretty large size wires. I don't see anything on the insulation. Well, they're good for 20 amps, right? I mean, it's got a 20 amp rating, so maybe we can test that. I don't know if I got 20 amps, but we can try. Wow, look at those. Those are nice. They're sharp. Man, these days everybody makes them really sharp, I think. But yeah, those come on and off easy. They just snap on right here. Alright, and as for the meter, you can see all the features and functions it has. You can see the settings here. The buttons are nice, just kind of rubberized like most buttons. I mean, they're nice. We're going to get the battery in. So to do that, we're going to take this off. You can see how it's ribbed right here where it grabs this edge. So we just pull it off like that. You can see how soft this is, so that's going to be protective. And this is like a lot of the flukes, you know, nice hard plastic thing that's in rubber. So yeah, it's a stand, right? And you also have, I guess, this little guy right here if you want to hang it on that. Now these things are soft but yet rigid enough to hold a probe firm. One of the things, I've seen some where they're so soft that when you put a probe in like this, and if you want to use it as a second hand, it's just way too flimsy. Now you can see it's got some flex, but it's definitely rigid enough to hold it. And there's your meter. Feels fairly light, very light actually. But everything looks like it fits nicely. You can kind of see for yourself, right? Okay, you know what? We're going to go tear it all apart right now. Alright, let's go ahead and open it up. Now they got a little thing here, get your finger in there. Okay, so it looks like it takes a couple double A's. And it has a plus minus, minus plus here. Now, obviously you can tell that when you remove this, the battery's not electrically connected anymore. Even if they're, you know, they're gonna, I'm sure, come off inside this case. And then you got the prongs here down on the board. So you have isolation from the board to your batteries. So there's the first layer of protection. Another thing is you have your metal insert here for your screw, so you're not going to wear that out taking it off and on, changing batteries. And also, I guess to point out, it's very easy to get to the batteries. You're going to have to get to the fuses by taking all 4 screws off. I can tell from these screws, the threads, that it's going into plastic, not a metal insert, which that's pretty typical. Alright, let's see how hard it is to pop apart. Oh, it comes apart nice and smooth. I'm going to play with that. Yeah, that's nice and smooth. Now, you see how big this ridge is here that sits down inside there? So, right away, that's looking good. Wow, that looks clean. That's my first thought just looking at it. It looks clean. Okay, I want to point out some things. You see this battery compartment? Look how it separates the fuses. So that's a nice touch. Now the buzzer goes up inside here, so there's a little hole right there in the two. That's pretty funny. So that's the buzzer. Man, I see some MELF resistors. It looks pretty simple, but I see some MELF resistors here. Big heavy traces. There's your shunt, kind of an M shape. There's some more MELFs. That looks like a PTC. Your crystal, your chip, and ceramic fuses. They're kind of not labeled, but they are ceramic. So 20 amps goes through this big guy through here, then out here. The lower current guy comes up through here, goes through there. Alright guys, so I guess you're going to want me to take this board off, right? I see 2 screws here. Now these prongs are all soldered to the board and then just inserted. These plastic things look like they give the strength to the metal to keep the banana plugs from spraying them out. There's a plastic feature in the plastic here that holds the board centered. There's, yeah, so we got 2, 4, 6 screws. Let's do it. Okay, I'm just going to pull on these, see if all my screws are loose. Feels like I have to loosen these a little bit more. Okay, I'm going to turn it over and get rid of the screws. Okay, we lost a button too. 2, 3, 4, 5, 6 screws. Something is holding it together up here. Alright guys, it's held together here, the display. See down there? You can see the connected, the little connection for the display up here on these pads. See that? But just from this view, you can see there's really no circuitry on this side. I mean, no components. There's the tracks for that. There's the little connections for the buttons here. And I can put this, see there's our little carbon guy there. I can put this guy back in. You can see our rotary knob, the connectors there. Yeah, so I guess to my surprise, I don't see any MOVs on this guy. I don't see diode protection for the current. Now when you put this back down, there's that plastic guy there, so it's making this contact up here on the display. Okay, so I guess we don't need to take it apart. Got some fuses, but we don't have protection for voltage spikes, things like that. So for category 3, category 4 type stuff where you could get those kind of spikes, I don't really believe that. I don't think this is category 3, category 4 rated. Especially with 20 amps. 20 amps is a big fuse. Well, this is a 20 amp fuse here. That's just a big fuse. You can see how it's stitched. I can see it on the other side of the card too. There's copper on the other side too. You can see the vias, they solder all the way through. But it looks very clean. I mean, again, that just kind of jumps out. It looks clean. I think this is going to be a great benchtop meter. We're going to take, we haven't even put a battery in yet, but we'll put some batteries in and check how it works on the bench. But yeah, definitely not good for category 3 or category 4 type work. Okay, I'll put all the screws back in and I'll be back. Alright, so I got the screws back in. One thing I do want to point out, see these fuses, if as far as dropping it, I don't see any physical plastic things to keep the fuses from shifting, but they do have the little metal kind of tabs. So those fuses are not going to shift during the drop. That is very nice. I mean, they did really set this up for 20 amps. That's a very rigid shunt, and that's some pretty heavy copper with support with solder. So I suppose that would handle 20. We'll find out. But I'll look to see if it's only supporting 24. It says max 20. I wonder if it's got a time duration. I'll look at the manual again. Alright, so got a couple batteries in this. They fit in there nice and snug. So let's just pop them down there. Wow, I heard it just beep on. Had the setting on. Let's get that screw in and flip it over. I like that battery compartment. That's nice. Okay. Now it looks like a nice display, right? Nice large digits, good contrast, nice clean looking. See what the backlight looks like. I guess you hold it down. There you go. Okay, it's kind of got a hot spot there on the side, right? It does light up the whole display, but it does have a hot spot. So, yeah. Hey, not too bad. So let's just look at the different displays. APO is auto power off, so it just tells you that it's microamps. Alright, so we got an EF, that's cool. We'll have to get some AC power over here to take a look at that. Okay, I'm going to hold the select down. And no auto power off. There's auto power off. So, alright, that works. Here, let's just test this temperature thing real quick. Let's just see if it... Test room temperature, I'm assuming it's in the volt. Yeah, there's temperature right there. Okay, there's AC, there's centigrade. Okay. Takes a while to heat that thing up. Yeah, it seems pretty close, right? 90 degrees from my hand. So, it's just nice little probe. Okay, one thing I like to measure, guys, is the diode voltage, just to see how many colors of lights we can turn on by, that's based on how many volts you get out on your diode test. There's K ohms. There's a diode function. So let's just see what the voltage is. Okay, 3.2. That's about average. That's good. Now the leads do come with these little stoppers in there. That helps get these from smashed if you store your leads in your case, so they might be worth keeping, guys. But we'll go ahead and put them on. If you leave them in your meter all the time, I guess not. Now you notice these are those angled kind of posts. Okay, they fit nice and snug. Yeah. Alright. So, diode mode. Alright guys, let's check it out. I dimmed my lights a little bit, and this guy here has several colors. Let's see if I hit the right one. Okay, there we go. So there's red. What do we get? 1.78, 1.9 almost, 2.28, and 2.5. So it turns on all those, no problem. 2.6. Yeah, no worries. It's going to turn on all these lights. This yellow one's really dim. 1.8. It's just a dim LED. Red one's a little bit better. 1.6. See what I mean? 1.8. So I like to do that 3.3 thing. Now, let's see this diode here. That's a Schottky. Look at that. 0.12. Now I keep the center leg, go to the other side. There's another diode. Now if I go center leg with red, it's open. Alright, so 3.3 volts is enough to check a lot of different types of diodes. Alright guys, let's do some resistance measurements. Starting off with continuity. Okay, I've got it in continuity mode. Hit select a couple times to get this. So turn over there, K ohms, continuity, and let's see. This is a 8 ohm resistor, I think it is. 4.8 ohms. I guess we can measure that, right? Let's go from top of the coil to the bottom. Oh, look, 5.9 But look at that, there's continuity. Doesn't mean we have it short. Means we have continuity. Oh, you guys like the fire starting method? Anyway, you know, it's got a nice loud beeper and it's latching, you can tell, and it's pretty fast, I think. Okay, I'm going to put the leads up in here, and that's annoying. Okay, right there it stopped, so I think it's below 50 ohms, I'm guessing. Let's take this down to, well, I'll put this to 9, and 49 ohms. Look at that. It's got to be 50 ohms. Right below that, it's going to beep. So if I go, yeah, so it looks like 50 ohms is continuity. Okay, now the other thing with the meters, see all these digits? Let's see. Now this guy here is 100K and continuity is way over. So let's just go to ohms. Alright, 100, and you know, this looks like about 151. So 100K and 51 ohms. That's like 101K. So I wonder if it's right. Okay guys, this meter here is 101 and it's kind of bouncing all over. Alright guys, I brought out the FLIR DM92 10161. And this is 100K, but it really does look like it's 101K, as if that's there. See, 102. So it really does seem like this is 1 kilo ohm off. Okay, now if I take that out, go back to this meter. Yeah, it really is close. I notice this guy kind of moves around a little bit. Alright guys, so let's see how many digits we can get. Okay, I got a feeling when I hit this one we're going to lose a digit. Nope, not yet. Yeah, there we go. Yeah, so there's all those digits you get with the 19,000 count. You know what guys, I swapped in my leads for my FLIR because it just seemed like it bounced around too much on those final 2 digits, but look at how solid that is. So it seems like there's something on the contact of one of these leads. It just kind of allows it to jump all over the place. Huh. Yeah, I'm wondering if one of those leads is damaged, but when I put these leads on, they're just solid as heck. Look at that. Solid. Okay guys, just wanted to show you the millivolt range here. Well, let's get millivolts here, I guess. So there's our millivolts there. Okay, so I wanted to get all the digits. Look at that, 10.4. That's probably my power supply that's moving around. Here, 10.34. Let's jump over this other meter just to see. That's interesting, the meter over here with nothing plugged in, it seems to want to take a measurement. Let's see if I go volts, nothing, but millivolts is pretty darn sensitive. It just kind of takes a charge by sitting there. Okay, if I take this guy out of millivolts, he kind of does the same thing. So the millivolt ranges, I guess, are pretty sensitive. 10.269. So let's pull out a meter that's a lot more expensive that has a bunch of digits. 10280 1 10280. So it looks pretty solid. 10281 10274. So yeah, it's, you know, I'm sure it's within the tolerance range, but that is nice that you get 3 digits after that. 10 millivolts plus 3 digits. Where you can see on a 6,000 count meter, I mean, this is a nice meter, but 6,000 counts only gives you 2 places. So that's the advantage of having so many counts, which you usually find in a more expensive meter. Okay, now we're reading milliamps, and there's some negative milliamps. Okay, look at that. We can go up to 19 milliamps with 3 places before we drop to 20. Okay, again, let's go to 6,000 count meter. 16, what is that? 16.57 and 17.06. So they're not in agreement. Let's see. Let's get somebody to break the tie here. Okay, 17.34. Wow. Looks like the amp probe might have been the one that was off. Yeah, 17.46. So that looks 17.52. I think the power supply up there, it kind of, in that real low level, it kind of moves around a little bit. 17.66. So let's move over here real quick. 17.6566. Okay, I brought in another one just to compare. 18.28, 18.3. That's moving around too much, darn it. 18.363. 18.3, 18.29. Alright guys, had a hard time believing my amp probe was so far off, so what I wanted to do is show you something. The shunt resistance inside, my power supply is probably being affected by how much resistance it's putting that small current through. So the Amazon has 1.74 ohm shunt current for the milliamp microamp setting. And this guy, 2.89, so it's a little bit more. Let's see what the amp probe was. Alright, look at this. This is kind of interesting. I don't know what kind of shunt resistance is inside here, but the FLIR sure doesn't like it. So that's interesting. I don't know how they're doing it. The one thing I can see is the battery is low on this guy, so that could be part of a problem, but this might have a different way of measuring the current. That's interesting. Has some really cool circuitry inside it. Okay guys, so I've got the generator set at 8 Hertz. It's coming in here, and here, let's just go here. About 8 Hertz, 50%. And it's 12 volts peak to peak, which that sounds about right, 4.3. Now I'm going to bring the frequency down. There's 6 Hertz. Look at that. I mean, you start getting so slow, it just has a hard time capturing it. So that's 3, 2, and that's 1 Hertz. And even at 1 Hertz, it has a hard. It's even having a hard time capturing the frequency. So let me go to amplitude. Okay, that's 20 volts peak to peak, no problem. Let's take back down. Okay, it's really about 13 volts peak to peak where it needs to have enough voltage to be able to pick up frequency. And even then it takes a moment, and it's 1 Hertz. See, if we go up to Hertz up here, that just has a hard time at 13 volts peak to peak. Let's go to 14, 15. Okay, that's 20 volts peak to peak, and it's really having a tough time reading 1 Hertz. So if I go to 2 Hertz, alright, no problem there. If I come back down to here, it's 19 volts peak to peak, and so it's having a hard time taking that reading at 2 Hertz. So if I go up, so that looks pretty close. That's probably correct. That's 9 or 10 Hertz right there. So yeah, so these low ranges, At low frequency, you need a little bit of voltage, or at low voltage, you need a little bit of frequency. So that's just something to be aware of. That's kind of interesting. Let's go to 10 megahertz. Okay, doesn't like that. Let's go up here. Up here in this frequency, it has no problem. Down here, it's not expecting that kind of frequency. Let's go to 1 meg. No problem here. So this guy down here, it's having a hard time reading the voltage or the frequency. Let's go to 1K. There we go. That looks correct. There's 1K, 50. I'm curious, 100K? Okay, that's too high. So when you're reading voltage down here, I think 1 or 2 kilohertz is a roll off for this. Okay, up here, no problem. Okay, let's just go from 100K to 10 meg and see how fast it goes. I'm going to push the button right now. Takes just a moment and pops right up. Okay, let's go to 1 hertz. And now I'm at 10 volts peak to peak, so I think the amplitude is a problem. So I'll tell you what, I'm at 20 volts peak to peak, and it just doesn't like the frequency right there. Let's go to 2 hertz. Okay, 2 hertz is just fine. That 1 hertz, just not happy with it. But if I'm in a square wave, watch this. Okay, that's a square wave 1 hertz. It's just fine with that. So that's interesting. I'm going to amplitude on 20 volts peak to peak, so I'm going to drop that down. Okay, we lost it. So I'm at 5 volts peak to peak. Okay, I need to be about 12 volts peak to peak on a square wave to get 1 hertz. Okay, let me go to pulse. So I'm at 1 hertz and 10% duty cycle, and that's correct. That's what I have set up. So let's go back to amplitude. Right now I'm 16 volts peak to peak. I'm wondering if I can go lower. It likes to have 12 or 13 volts peak to peak. And everything's fine. So yeah, these extreme ranges at the low end, at real low frequency, you need some voltage, 12 volts peak to peak. Or you need to go up a little bit in frequency. But at 1 hertz, you need a little bit of voltage there. So let's check out the true RMS feature. We're going to ramp up the frequency. First I'm going to put 1 volt there. Okay, there's our 1 volt, slightly over. Okay, now let's go ahead and increase frequency. It's 1 kilohertz right now. So let's see if we go to hertz. Yeah, almost 1 kilohertz. Duty cycle is 50%. Okay, so there's our 1 volt. Here, you'll be able to see the frequency change there. There's 2K. Let's just go up to 5K, see if it's good there. No, it's only good to 1K, I think. A lot of meters are only good to that frequency. I'm at 2K. No, 3K, 2K. Okay, so it's good to 2 kilohertz. And at 3 kilohertz, look at that. So it's about a 3 kilohertz because it's down, 0.7. But yeah, 0.2. But at 2 kilohertz, you're getting a good reading. So, alright, that's good. Now, you know what? Let's go to the square wave. Okay, there's square wave. I'm going to go 1 volt RMS. Okay, so we're just a little bit low at 2 kilohertz. Okay, there's 1 kilohertz. Yeah, so it's pretty solid. Okay, I'm down at 500 hertz. There's 100 hertz. So let's just go up in frequency. Dropped a little bit there around 500 hertz. Let's go where we're 0.7. Okay, so that's about, yeah, it's almost 3 kilohertz. That's 2 kilohertz. So yeah, it's not bad. True RMS. Square waves are hard to read in an RMS meter. You have to have true RMS to get good readings because of has to read the harmonics, which are higher frequency. There are multiple frequencies above your 1K, right? So your second harmonic's 2K and so on. Third harmonic's 3K. Alright guys, I got it hooked up to my HP here. It's capable of 15 amps for sure, maybe a little bit more. And right now it's putting it out about 1.2. I've got the voltage maxed out. I just have to adjust the current up. Current's going to 20 amp setting, so let's go ahead and do it. Wow. Okay, once I go over 10 amps, yeah, once I go over 10 amps, that meter starts to complain. See how high we can go. Okay, we're about almost 16.5 amps. Leads are fine. They might be starting to get warm. That's kind of annoying, right guys? I'll probably turn the volume down in the video so you don't have to hear that. Okay, leads are just slightly warm, not bad. Now when I use these IR meters, they actually seem to read through the insulation. I'm only seeing not very high temperatures. Maybe in the 40°C area. Yeah, in the 50s, it's approaching 60°C maybe, in the high 50s. But that's got to be the copper inside. I can feel if I hold it long enough, the copper inside, but the insulation on the outside is not bad. So yeah, it is getting kind of warm. Alright guys, let's go to capacitor. Okay, nanofarads. Now this guy is Cornell Dubler, 6800 microfarad. So this should easily read it because it can go almost to 10. So negative lead, stripe. Wow, look at that. Okay guys, this should be a 0.1 nanofarad. And it is. Alright guys, I have this in EF mode. I had to go get my extension cord. So, okay, it looked like you had 2 bar, oh look, 3 bars, 1 bar, nice. Alright, so let's try this relative mode, okay? So let's take our ohms. Let's say we're going to read this 1 ohm resistor, but we want to zero out our leads. Okay, 0.0. Wow, if I hold it there long enough. Okay, say 0.03. Okay, 0. And if I go up here, and if I wait until it settles out. Okay, there's the ohms, maybe 102. But if I take it off relative, if I go read it again, let's wait until it settles out. Yeah, so it's 106. So that relative helps you zero out your leads if you're doing resistance, or if you're doing voltage or current. You can do the relative reading, which was take your reading. Let's say at 10 milliamps, you could hit relative. It'll zero that out, and then you can maybe you're going to watch a battery discharge. You could go 1.5 volts, zero it out, and then watch it the voltage change over time. Alright guys, so what do you think? Nice meter, right? I think it's around $32. I'll put the link down below. I'll tell you what, the leads seem to a little bit flaky. I'm going to investigate that a little bit more. But I'm going to give both these meters away, and I'm going to check out both leads, and we'll see what we can do there. But if you're in the States, I'll pay the shipping. If you're outside the States, we'll have to talk about that, okay? Send me an email that you want it, kissanalog@gmail.com, and like the video, be a subscriber. I'm going to give one to Patreon and one to the general public. Hey, thanks for watching the videos, guys. We have 5,000 subscribers. That's awesome. That's pretty cool, and appreciate everybody. And thanks, patrons, for supporting. And you can become a patron for as little as $1 a month. All right, we'll see you guys. Thanks.